All right, hello everybody. This is Mrs. Masteller again, and we are starting Chapter 8, starting with Section 1, titled Multiplying and Dividing Rational Expressions. So first, just knowing what a rational expression is. So the definition at the top, again, to be rational, again, you want to be thinking about ratio. See the word ratio and rational, and a ratio is just a fraction. So when it comes down to it, rational expressions, and these first three going across the top, these are all rational expressions. So if you had to write this out in words, what it is, it's a quotient. Quotient just means division problem. In other words, technically a fraction. So again, those are three examples down below. But it's a quotient of two polynomials. So on the top you'll have a polynomial, on the bottom you'll have a polynomial. We'll just say p of x over q of x, where q of x cannot be equal to 0. So you can't have 0 in your denominator because, again, that makes the function undefined, which we'll talk about that in just a second. But again, all three of these examples going straight across, these are all rational expressions where you have a polynomial in your numerator, polynomial in your denominator. Okay, so the question is underneath, it says, under what conditions is each polynomial undefined? So again, the question is basically, what makes this all 0 in my denominator? What value can x not be? So there's one number x cannot be in this whole entire situation, because otherwise that will give me 0 in my denominator. So we can't have 0 in the denominator. That's bad, makes it undefined. So one number x cannot be, so just even looking at it, the one number x cannot be, can't be -2. That makes it undefined. So if x were -2 in your denominator, you would have -2 plus 2. And we know that -2 plus 2 is 0. So it's the one number x cannot be. So for the middle one, same idea. The one number x cannot be, well, there's actually two values. And just by looking at it, it's kind of hard to tell exactly what x cannot be. So you're thinking, well, if I square this number and then subtract it by 6, somehow that gives me 0. So how do we get that value? If you don't know by looking at it, what I'm going to do, again, here's the question, what makes a 0? Right? That's the question. What makes my denominator equal to 0? So just set it equal to 0, solving it, add 6 to both sides, and then we would take the square root. And like I said, there's actually two values. X cannot be positive or negative square root 6 in this circumstance. Okay, again, once you take the square root of two sides of an equation, the square root property says you get positive and negative values. So if you plug those into the original problem, just in your denominator, so like if I plugged in positive square root 6, I'd square it and then subtract it by 6. Well, we know that when we square a square root, those just cancel. So that would be 6 minus 6. And again, that gives me 0. And then same thing too, if you plug in negative square root 6. So if I have negative square root 6 squared minus 6. Well, if I square a negative, I'm technically squaring, that's a -1 if you think about it. Square -1 and square the square root, that'd be +1, -1 squared. And the square root of 6 being squared, that's just 6 again. And once again, you get 0. So again, there's two values x cannot be. Those two values make it undefined. And the last one, just even looking at, we should be able to tell the one value that x cannot be +2, because that would make it undefined. Because again, you'd have 2 minus 2 in your denominator. That gives you 0. That is bad. Okay? So this kind of explains more so how we're going to tell what values make it undefined. So it says when you're identifying values for which a rational expression is undefined, you're identifying the values of the variable that make, here's the key words, the original denominator equal to 0. Okay, so I'm going to talk about that in these next examples. So we're trying to simplify in A, B, and C, simplify each of these expressions, but you also want to identify any x values for which the expression is undefined. Okay, the way we're going to simplify, simplifying is really just saying reduce down the fraction. Okay, and one thing I do not want you guys to do, here's how you do not simplify these. So a lot of people for the first one, they'll see like the x squared and x squared, they'll just want to cancel those out right away. You can't do that. Okay, what my teachers always used to say back in the day is they would say that these terms are married. They travel together all as one whole unit. So you can't just separate it and splice it up how you want to. It travels as one whole unit. So you can't just individualize all the terms. Okay, how you're going to reduce this down? You want to factor. Factor everything that you possibly can. So in my numerator, I'm going to factor that out first. So on top, if I factor, I'll just set this up for numerator and denominator, but on top, just thinking about what multiplies to be -2 and then adds to be a +1, well, that would be 2 and then -1. On the bottom, how this factors in my denominator, so what multiplies to be -3 adds to be a 2, That's positive 3 and negative 1. Okay, so now's the point where we are going to be reducing down this fraction. However, before you do so again, we have to state what makes this undefined with the original problem. So before anything cancels out and goes away, what makes this undefined? Two values in this case because you have two binomials in your denominator. X cannot be negative 3 for the first one, and x cannot be positive 1. Those two values make it undefined. Now you go ahead and cancel. The x minus 1s, those cancel each other out. And now final answer would just simply be on top you have x plus 2, on bottom you have x plus 3, and voila, you simplified the rational expression, and you also stated what makes it undefined. Okay, it's as easy as that. So similar idea for b, same exact idea. So if I start to factor on top, you have the x squared already in the front, but factoring the trinomial, this would factor into x plus 3x minus 2. On the bottom, as far as factoring goes, just take out your GCF of 4x. You'd be left with x minus 2. Okay, so again, go ahead and state what makes this undefined. Two values. Since you have two terms, you have 4x and x minus 2. X cannot be 0 because that would make my denominator undefined, and x cannot be positive 2. So those two values make it undefined. Now start canceling. X minus 2's cancel. You can also cancel in the monomials, the x squared and the 4x in the bottom. You can cancel down an x. So the x in the bottom cancels, and you'd be left with x the first on top. So if you clean this all up, what you have left is you have x plus 3 in your numerator over just 4 in your denominator. That'd be it. Okay, and then for C, go ahead and factor. So numerator and denominator. Numerator is going to be kind of a pain since it's guess and check, but the denominator is not too bad. Difference of squares, that's just x minus 7, x plus 7. On top now, to factor, again by guess and check, 2x squared is 2x and 1x. And now the rest of it, so again, filling out the rest of the binomials, it's just a matter of what multiplies to be 7, and just figuring out where does 7 go and where does 1 go. Because again, when you FOIL this back together, you need negative 15x once you combine like terms. So it has to be 1 times 7. Those are only two numbers that multiply to be 7. 1 times 7. So where does 7 go? I'm going to say over here, and 1's going to go over here. If I want that to be a negative 15x, these would both have to be negative because it is multiplying to be positive 7 as well. Okay, so again, got it factored. Now, stating what makes this undefined, two values, x cannot be positive or negative 7 based on my denominator. And now canceling the x minus 7s. Final answer is just 2x minus 1 over x plus 7. And that would be it. Okay, so again, we're really just reducing down a fraction. We're trying to reduce it as much as we can and then stating what makes it undefined. These next three examples, we are going to simplify. It says using negative 1. So I'll kind of explain what that means, but it does say to assume that all expressions are defined. So you don't have to actually say what makes it undefined. So we're assuming that it's already defined for us. Okay, so just simply, we're trying to just reduce down the fraction is all we're trying to do. But we're using negative 1. So for example, in example 2a, so even look at the top part, my numerator, I got 3y, and then in parentheses we have the 7 minus y. Technically, this isn't even in standard form. Okay, technically speaking, what that should be is 3y, and then negative y plus 7. So I'm just going to start factoring. We got y minus 7 in the bottom, and then we also have y minus 3, y plus 3 when we factor the difference of squares. Okay, we're using negative 1 because if you look, these two binomials obviously look very similar, but they're not exactly the same. Okay, because you got a negative y on top, positive y on bottom, positive 7, negative 7. They're similar, but we can make them the same by using negative 1. So on top, what I'm going to do in my numerator, I'm going to factor out a negative 1 from the negative y plus 7. So when I take out that negative 1, what that's going to do is now we would have negative 3y in the front. And if I divide the negative y and 7 both by negative 1, now I have positive y and negative 7. Now I can actually cancel something down. Now that they're perfect matches, they got to be perfect matches. So they have to be exactly the same. Matching up y minus 7, y minus 7. Boom, those cancel. So my final answer would be, we got negative 3y on top over y minus 3y plus 3. So nothing else reduces down. Nothing else is going to cancel. That would just be it. Okay? So similar idea for b. So on top, I'm just going to go ahead and start my factoring. So my numerator, we got the p squared already. This would factor into p minus 3, p minus 1 in my numerator. So So the trinomial, and again, on the bottom, technically it's not even in standard form. So those two terms, if you switch those two around, hopefully we'll be able to see what to do. So let me just do it right next to it. This would be negative 3p squared plus 9p. So now in my denominator, if that's my new one, once I switch the terms around, just take out your GCF, which I'm going to take out between negative 3p squared and 9p. I'm going to take out negative 3p. So now I'd be left with p minus 3 in my denominator. Okay, once again, canceling. We got it all factored. P minus 3's cancel. So those match up. And then again, you can reduce down the p squared with the p. So the p on the bottom cancels all together. You'd be left with a p on top. So cleaning this all up, what do we have left? In my numerator, I have p and p minus 1. On the bottom is just negative 3. And there you go. Okay, so similar idea for the next one too. So for C, last one, change my color again so it stands out. On top, I'm going to go ahead and take out my GCF, which is a to the 4th, and then I have b minus 2 left. So it looks like we're going to do the same for the bottom portion too. Take out the GCF, which would be a cubed, and now we have 2 minus b. And again, you could see that those two are very similar, the top and the bottom. So looking at those two binomials, b minus 2, 2 minus b, they're similar, but they're not exactly the same. So what I'm going to do is in my denominator now, I'm going to fix it. I'm going to keep my numerator. But in my denominator, I'm going to go ahead and take out a negative 1 from both of these terms. So now I'd have negative a cubed. And when I take out that negative 1, I now have a positive b, but a negative 2. Okay, I also obviously switched it around too. So now they are perfect matches, those two binomials. So I'm going to go ahead and cancel those down. So now we have a to the 4th over negative a cubed. Well, those obviously reduce as well. This would cancel all together. I'd be left with an a, negative 1 the bottom. So I have a over negative 1, but that would just be negative 1a as my final solution. Okay, so all we've done so far is learn how to basically reduce down these rational expressions. Again, it's just really reducing a fraction. Okay, we know what it means to be undefined as well. We haven't even really started multiplying or dividing just yet. So if I go on to the next page, now we're going to be multiplying and dividing. So the directions for example 3, we're going to multiply all three of them, and then again it says assume that all expressions are defined. So we don't have to actually say what makes them undefined. When you have monomials like we do for A, so we have monomials all over the place in my numerators and also my denominators, I think it's easier to just multiply straight across and then do the reducing at the very end, just so it doesn't turn into a giant mess. So again, only with monomials, if I multiply straight across my numerator, 3 times 10, so that's 30, x would be to the 8th, y would be to the 7th. Now my denominator, I'd have 18, x would be to the 5th, y would be to the 12th. Okay. Here's my answer. I multiply the two together. Now reduce this down. So 30 over 18, I would divide those both probably by 6 is the biggest number. So that'd be 5 and that'd be 3. So far I have 5 over 3. Reduce down the x's now. It's not going to need to be that big, but reducing down the x's, the 5 would go away. We'd have 3 left on top, 8 minus 5. And then with the y, since you have more y's on the bottom, y is going to be on the bottom, and that's y to the 5th power. The 7 cancel, and those reduce down to 5. And that'd be your solution. Okay, but when you have binomials and trinomials and things of that nature, don't multiply straight across. Do not multiply. Instead, what you're going to want to do is factor and cancel. Factor everything that you can, cancel whatever cancels. So for example, for B, x minus 3 is still x minus 3. Underneath it, though, take out your GCF, which is 4. You got x plus 5. Times this by, again, top cannot be factored, so x plus 5, but underneath it, difference of squares, that does factor. Okay, so it's all factored out. When you're multiplying with fractions, what you can also do is you can cross cancel before you multiply. So cross cancel, not cross multiply, but cross cancel. So like these x minus 3s, those can cancel out. X plus 5s, those cancel out. What do we have left? On top, we technically have 1. So if everything's gone on top, these technically all reduce down to being 1s when they canceled. So you have 1 on top, you have 4, x plus 3 on the bottom, and you can leave your answer just like that. Okay, you don't have to redistribute the 4 or do anything like that. And then for C, for the next one, so again, just factoring it out, on top, take out the 10, your GCF. Underneath it, this factors into x minus 4, x minus 2, times this by x plus 3. Take out the GCF underneath. Okay, it's all factored. Now find your matching pairs. X plus 3's, one on top of the other, those cancel. Same with the x minus 4's. You can even cancel the 10 and the 5. Those also reduce down. So dividing those both by 5, that's a 2, that's a 1. So what do we have left? On top is 2, on bottom is x minus 2. And that'd be it. And again, those 2's do not reduce down, so you can't cancel down the 2 over 2. Okay? Now it's division. So how do you divide with fractions? Well, you don't divide fractions. Instead, you multiply by the reciprocal. Okay, and again, it says to assume that all expressions are defined. So what we're going to do, you keep the first one all the same. You change this now to multiplication, and then you flip this around. Again, you multiply by the reciprocal. That's how you divide fractions. And I always call this KCF. Just stands for keep, change, flip. You keep the first one the same, you change the problem to multiplication, then you flip the second one around. Okay, so again, with monomials, what I'm going to do, I'm going to go ahead and multiply straight across. Or actually, I can do a little bit of reducing. Just like these 8s, I'll just go ahead and cancel those down. It'll make the math easier. 5 and 15, can make that 1, make that 3. So on top, we have x the 4th, y to the 5th. On the bottom, we have 3x squared, y squared. Now I'm going to reduce down the x's and y's. So reducing those down, these x's go away. I'd have 2 left on top. These y's go away. I got 3 left on top. So I have x squared y cubed over 3 is my solution. Okay, the next one, similar idea. Again, what I'm going to do first, though, is I'm going to keep this one all the same. Change this now to multiplication, and then flip this guy around. So just keep, change, flip. Okay, this one's not going to be too fun to factor, but that's okay. We can manage it. The first fraction, I'm going to actually start with my denominator because that's easier. That's x minus 3x plus 3. And might as well do the second one too on the bottom. That's also a difference of squares. That's 2x minus 1, 2x plus 1. Okay, I always suggest to factor the easy ones first. I forgot my plus sign in this one. Plus 3. But factor the easy ones first because oftentimes those will help you factor the harder ones. So now if I kind of backtrack to the 2x squared minus 7x minus 4, well, I know it's going to be a 2x and a 1x. And now what's the rest of it? Well, again, if you look at the bottom, you have 2x minus 1, 2x plus 1. One of those two might be over here with the 2x squared minus 7x minus 4, factoring it. So just thinking about, again, the rest of the binomials have to multiply out to be negative 4. So it has to be 1 times 4. I'm going to guess 1 is with 2x and 4 is over here, just to kind of match it up here. Okay? Now playing around with the signs, well, if it has to add to be negative 7x, I need negative 8x when I FOIL plus 1x. So the 2x plus 1s are going to cancel, basically. Okay? So the easier ones sometimes are an indicator on how the rest of the problem is going to unfold. The 8x squared minus 28x plus 12, first of all, you can take out a GCF between all three, which is 4. So if I take out a 4, now I just have 2x squared minus 7x plus 3, so that makes it easier. So I have 4. Now factoring the 2x squared part, again, that's 2x and 1x. Multiplying to be 3 has to be 1 times 3. Again, I'm going to guess 1 is here, 3 is here, and then they have to add to be negative 7, so they both have to be negative. Okay? So hopefully that helps you out a little bit, but now you can start canceling. So like the 2x plus 1s, the x minus 3s, the 2x minus 1s, look at all that canceling. So all we have left on the top in my numerator is I have 4, and x minus 4, and I have x plus 3 in the bottom. That is it. Okay, and then doing the same thing too for the last one for C. I'm going to erase all this stuff just to give myself some more room since I'm writing kind of big here. So I'm just going to clear all that. The last one for C, again, I always suggest just simply write out this first step, keep the first fraction the same, change it to multiplication, then flip it around. Don't try to factor and do everything else all in the same step. Just simply do this as your first step and now start to factor. Okay, so starting in the top left, x to the 4th minus 9x squared, take out a GCF of x squared first, but you're going to have x squared minus 9 left, which is still factorable. That'd be x minus 3x plus 3. Underneath it, trinomial, this factors into x minus 3x minus 1. X squared minus 16, that's just x minus 4x plus 4. And now underneath, again, you do have a GCF of x squared. So if you take out an x squared from all of these, you'd have x squared 2x minus 8 left, which would factor into x plus 4, x minus 2. Okay, so it's all fully factored. Canceling now, x minus 3's go away, x plus 4's go away, x squareds go away, and now what we have left, that's about all I can do. I have x plus 3, x minus 4. On the bottom, we have x minus 1, x minus 2. And that would be your complete solution. Okay, so again, just factoring and canceling is all you got to do. At the bottom, we have complex fractions, which is basically we have fractions inside of fractions in a way. It's the way I look at it. But again, you're simplifying. With these ones, a complex fraction is really just another way to write a division problem. You have a fraction on top, and it's being divided by the fraction on the bottom. So it's another way to write a division problem. So if you're dividing again, you're just going to keep change flip. Keep the first one the same, change it to multiplication, flip the second one around. So to finish up here, again, we're just really dividing two fractions. So for example, 5a, what you would do, again, you're going to keep the first one the same. So a squared b squared over x squared y cubed. And now we're going to times it by the reciprocal, which is xy squared over ab. So you can multiply straight across if you want to. You can also cross cancel before you multiply. So like these x's, for example, that one would cancel. You have an x on bottom. The two y's would cancel. You'd have a y on bottom, canceling the a and the b. So the a cancels, you got an a left. B cancels, you got a b left. So our answer would just be ab over xy. And there you go. So similar thing for the next one. If we set this up, we got x plus 1 over x squared minus 1. Now we're timesing by the reciprocal, x minus 1 over x. Okay, so factor now. So factoring, looks like the x squared minus 1 would factor. That factors into x minus 1, x plus 1. And then as far as canceling, x plus 1's cancel, x minus 1's cancel. My answer is just 1 over x, and that'd be it. So 1's left on top, x is on the bottom. Last one for C. So setting up, we got x squared over 9x squared minus 4y squared, timesing by 2y minus 3x over x cubed. So keeping, changing, flipping. Factoring wise, the 9x squared minus 4y squared, that's a difference of squares. So that factors into 3x minus 2y, and then 3x plus 2y. Okay, so just kind of scanning around. Is anything going to cancel? Well, the x's do cancel, x squared and x cubed. I can cancel that down. Got x left on bottom. And then if you look carefully, the 2y minus 3x is similar to 3x minus 2y. So what I'm going to do in my numerator is just take out negative 1 from both of these terms, which would make this now positive 3x minus 2y, just basically switching around the signs. And now we can actually cancel 3x minus 2y. So what do we have left? In my numerator on top, all I have left is negative 1. On the bottom, we have x, and we also have 3x plus 2y. And that is it. All right. So there's your new lesson. Again, multiplying, dividing rational expressions. Let us know if you have any questions as usual. But hopefully you found this useful. And we will talk to you later.